Lesson 1-6. Today we're going to solve compound inequalities. We're also going to use interval notation, and then we'll save absolute value inequalities for the next day. So a compound inequality consists of two inequalities joined together by the word and or the word or. If they are joined by the word and, we call them an intersection, and their graph is the intersection of the two graphs. Here's a picture. So if we have x is greater than or equal to -1 and x is less than 2, we have to satisfy both inequalities at the same time. And so we're going to look at just the solutions from -1 to 2, including -1 but not including 2. So we want to figure out where do the graphs overlap, which values satisfy both inequalities. Here's one example that we can solve. 13 is less than 2x plus 7 is less than or equal to 17. We really have two inequalities joined together here. You can tell because there's two inequality signs. And when they're put together like this, we call it a intersection. Even though you don't see the word and, this is an example of an intersection. What we have to do is get x by itself in the middle. Okay, so we're going to undo the plus 7 and we're going to undo the multiplying by 2. So your first step is to subtract 7. So we're doing that in the middle, but we're really solving two problems in one here. So I also need to subtract 7 from both endpoints as well. So 13 minus 7 is 6 is less than, use the same symbol, 2x, 7 minus 7 cancels out, and then we've got less than or equal to 17 minus 7 is 10. Okay, so I've subtracted 7 from the middle, but also both endpoints. Now I need to divide by 2, and when I do that, I'll be left with x, but now I need to divide both endpoints by 2. So 6 divided by 2 is 3. I'm going to use the same symbol here, less than, x is in the middle, and then I've got less than or equal to 5. Now what this says is x is greater than 3. Look at the way the symbol is pointing here. If you start with x, it's opening up towards x here. So x is bigger than 3, but x is less than or equal to 5 at the same time. So when you graph your solutions, obviously you want to include 3 and 5. So I'm just going to put 3, 4, and 5 on my number line. The symbol on the left tells us to use an open circle on 3. The symbol on the right tells us to use a closed dot on 5. So you can start by putting the dots on both endpoints. And what this really says, another way to read it, is that x is in between 3 and 5, including 5. So my shading should go in between the two dots. Okay? Now, what would be some solutions here? Anything bigger than 3 and less than or equal to 5. So does 3 work? No. Does 4 work? Yes. Does 5 work? Yes. And then, of course, any decimals in between those numbers would work too. A compound inequality that uses the word or is called a union. Let me underline or up here. It's a little different than an intersection. When you're solving a union, you're saying one thing or the other thing. So actually, both of them are true at the same time, okay? So if we have the example x is less than or equal to 1 or x is greater than 4, we're saying that either or here would work. So you can actually include both parts of the solutions on the same number line. Take a look at the example. X is less than or equal to 1 or x is greater than 4. So we don't have to have anything that overlaps here. Anything to the left of 1, including 1, is a solution, or anything greater than 4 is a solution. Here's an example. Y minus 2 is greater than -3, or y plus 4 is less than or equal to -3. Okay, let's solve them both separate. We really have two problems in one here. So in the first one, I'm going to add 2 to both sides, and I get y is greater than -1. Or there's another part here. In the second one, I'm going to subtract 4 from both sides, and we get y is less than or equal to -7. So y is greater than -1, or y could be less than or equal to -7. They don't both have to be true. It's one or the other. So you make your number line. Okay, and on my number line, obviously I want to include -1 and -7. -7 should be on the left, and -1 should be over here on the right. Okay, and let me just put, I don't know, maybe one more number in here, -4. Okay, so my two endpoints, I always start with those. On -7, the symbol less than or equal to, with equal to underneath, tells me to make it a closed dot on that number. And then greater than -1, strictly greater than, tells me to use an open circle there. Okay, so if y is greater than -1, that means from this endpoint, our solutions are to the right. And if y is less than or equal to -7, -7 is a solution, and then so is everything to the left. Okay, so the difference between a union is really that you're putting two graphs together. It's one or the other. When you're solving an intersection, you have to figure out where the solutions overlap. So you've got an intersection and a union, and you can go back and review those examples. Okay, the next thing we're going to do here, if you choose to, you can open your book to page 40 and follow along, but we're going to talk about interval notation. Instead of using a less than sign or a greater than sign, we can use interval notation. So if you look at my first example here, instead of writing x is less than 2, you can write it as the interval -∞ to 2, using parentheses and a comma between them. Infinity symbols are used to indicate that a set is unbounded in a positive or negative direction. So if you have greater than, you're going to positive infinity, or greater than or equal to. Think about it on the number line, you're going to positive infinity. If you have the symbols less than or less than or equal to, that means you're going to negative infinity, all of the negative numbers. To indicate that an endpoint is not in the solution set, in other words, if you have an open dot, or a greater than or strictly a less than sign, you're going to use parentheses around that number. Parentheses are always used with infinity signs, and this should be a -8, shouldn't it? Okay, so if you have x is greater than -8, because it's strictly greater than, you're going to use a parentheses to say that -8 is not included, and then greater than means we're going to positive infinity. So the interval is from -8 to positive infinity. You're going to use a bracket to indicate that an endpoint is included. So if you would make a closed dot, or if you have an equal to underneath your symbol, that means put a bracket around the number. So x is less than or equal to 2. If you think about it on the number line, you're shading to the left to the -∞. So that's where you want to start, and then your endpoint is 2 with a bracket because 2 is included in the solution set. Okay? Parentheses are always used around infinity or negative infinity. The other thing to keep in mind is that positive infinity should be on the right in your interval. Negative infinity should always be on the left in your interval. Let's practice some of these. Oh, one more thing. If you have a union of two sets, you can use the symbol U. It's basically a capital U. So if you have one or the other, you can use a U in between them. So let's look at this example. Y is less than or equal to -7. Look at the interval here. Less than or equal to means start at negative infinity. Your endpoint is -7, and I've used a bracket because of the equal to underneath the symbol. Or use the union between. Y is greater than -1. Greater than means we're going to positive infinity. So I'm starting at -1. I've used a parentheses this time because it's strictly greater than, and we're going to positive infinity. Now let's try some examples. We're starting out with the inequality sign, and we want to rewrite them using interval notation. So if a is less than or equal to 3, that means I'm going to negative infinity. So less than or equal to means negative infinity. So it's going to be a parentheses, start with negative infinity on the left. My endpoint is 3, and because it's equal to 3, I'm going to use a bracket. So parentheses are always used with infinity. Start with negative infinity on the left. The endpoint is 3 with a bracket. Number 2, n is greater than -2. Well, greater than means I'm going to positive infinity. So this time I'm going to start with my number -2. I'm using a parentheses because I don't have an equal to underneath. In other words, it's strictly greater than -2. And because it's greater than, we're going to positive infinity. So my interval is from -2 to positive infinity. In other words, greater than -2. And now we have a compound inequality, a union, with the word or. So you just do each one separately and combine them with the capital U. Y is less than -2. Less than means we're going to negative infinity, so I'm going to start there. 2 is my endpoint. It's strictly less than, so I need to use a parenthesis. Or means use the union sign. And then my second one is y is greater than or equal to 14. Greater than or equal to means we're going to positive infinity. So this time I'm going to start with my number first, 14, to positive infinity. And I've used a bracket around 14 to show that this endpoint is included. In other words, if you have greater than or equal to, you need to use a bracket. Okay, and the last thing that we're going to practice is graphing solutions on the number line. And notice that these solutions are written using interval notation. So, number 1, this interval says that the solutions are from -1 to positive infinity. So when you go to graph it, you want to put -1 on your number line. Positive infinity means we're going to the right, positive infinity. And now you have to look, is it a parenthesis or is it a bracket? Around -1, I've got a parenthesis. That tells me that -1 is not included. In other words, we use an open circle. So -1 to infinity looks like this on the graph, on the number line. Number 2, negative infinity to positive 4 with a bracket. Okay, so negative infinity means it's less than. In other words, we're shading to the left. So I'm going to start by putting my number on the number line 4. The bracket around 4 tells me it's a closed dot. And the negative infinity tells me the shading goes to the left. That's the graph. Okay, and the last one, number 3, notice we've got a union. They're connected by a U here. I've got negative infinity to 5 with a bracket. And then 7 to positive infinity. So I need to put 5 and 7 on my number line. Okay, on 5, the bracket tells me that there's a closed dot. The negative infinity sign tells me that it's less than or equal to 5, so shaded to the left. From 7, we're going to positive infinity, and I have a parenthesis. The parenthesis means on 7 we have an open dot. Positive infinity means the solutions are to the right of 7. That's how you can graph the last one. Okay. All right, so for your check for understanding, what I want you to do here is solve and graph each inequality. So I've got 2 examples or 2 prompts here, just like the examples we worked out together. And then I want you to practice writing your solutions in interval notation.